Okay, so we're going to go to the notes from yesterday, topic 1.11, and go to the second page, to the front of the second page. And it talks one of the things, actually, the main thing we're going to do today is find the slant asymptote. And so sometimes a rational function has a slant asymptote, and this is what it looks like. So it's a slanted line that as you go to the right and as you go to the left, the graph will approach. But there's only a limited amount of time when you have one. So a slant asymptote, the degree of the numerator has to be exactly 1 greater than the degree of the denominator. So could you ever have a horizontal asymptote and a slant asymptote? No, because whenever the degree of the numerator is greater, there is no horizontal asymptote. So sometimes when there's no horizontal asymptote, there is a slant asymptote. All right, so we have this function. I think this is the one that's graphed. So we have it in multiple representations. We have it in factored form and then the original form. And you can tell that there is a hole at x equals 2 because of this guy right here. And there's the hole. There is a vertical asymptote at -1 because of this guy. There is a 0 at 0 and -2 because of those terms. And there is no horizontal asymptote. So what this one does have is a slant asymptote. The equation of that line, the slanted line right here, is y equals x plus 1. We aren't really going to graph a lot of slant asymptote lines, but it has a y-intercept of 1 and a slope of 1. And the reason there is a slant asymptote is because the numerator degree is exactly 1 more than the denominator degree. And to find it, and we're going to find it in a second, find 1 in a second, you divide the denominator by the numerator, and you end up getting x plus 1. And that's the equation of the slant asymptote. Okay, so before we start finding slant asymptotes, we do need to know how to divide polynomials. And so when you divide polynomials, you have 2 options. You can do synthetic division and you can do long division. So synthetic division is great. Like even when you look at your steps, it looks like there's a lot of steps, but that's only because it's really difficult to articulate what you do with synthetic division. But the problem with it is it's very restricted. You can only do synthetic division when you're dividing by something like this, where it's just like x plus a number or x minus a number. If there's ever a coefficient other than 1 on your x, you can't do it. If there's ever a power other than 1 on your x, you can't do synthetic. So it's great when you can use it, but it's extremely limited. So let's do, if I can do synthetic division, I do it. And so if you look at your steps, when you do synthetic division, the first thing you do is you draw this little box. That's how I draw it. Your algebra 2 teachers may have drawn it a little differently. I don't know. Do you guys remember what number goes in the box? The opposite of this, right? So this is going to be 3. Nice job. Right, and if you're just looking at the bullets on your paper, the coefficients of the dividend, which is this, go to the right of the box. Now you have to be super careful. If there was a term that was skipped, what do you fill in for it? A 0. So we did have a term that was skipped, the x squared term. So when I write my coefficients, in the place where x squared would have been, we have to put the 0. We have to put it there, or you're going to be doing the wrong division problem. All right, and then you leave a little space and draw this line. Right. So this first coefficient to the right of the box, you bring it straight down. And then from here to the end, you're multiplying and adding. So you multiply the number in the box by the number under the line, and then you add. And then you do it again. You multiply the number in the box by the number in the line, and then you add. Now sometimes these get kind of big and it's hard to do in your head, but same thing, multiply. And then you add. Now this is not the answer. These are the coefficients, the constant, and the remainder of your answer. So I'm going to move up to the division algorithm. Now, it sounds like that's something hard when you hear the word algorithm, but it's just two different ways to write your answer. Now in Algebra 2, they might not have called it the division algorithm, but I'm guessing this is how you wrote your answer. So these give you the quotient, and this gives you the remainder. So we originally took x cubed and we divided it by x. What should that take it down to? X squared. So when I write my answer using that first division algorithm, this is going to be 2x squared plus, and then a 6, and then that power is just going to go down, plus 14. And then what this means is you do the remainder divided by the divisor, which in this case is g of x. So plus 2 over x minus 3. Does that feel familiar to you, I hope? Okay, you guys remember synthetic, good. All right, there is another division algorithm that they specifically mention in our standards. I don't know how they're going to put it on a test, but I want to show it to you just in case. Where they take the g, which was this, multiply it by the quotient, and then add the remainder to it. And that should give you the original function, the dividend. And that's actually what I do when I'm making up these problems, and I want it, especially a long division problem, and I want it to turn out nice. I use that algorithm to figure out what dividend I want. So anyway, we're going to take g, which was x minus 3, we're going to multiply it by q, which was what we had right there. And then we're going to add the remainder to it. So it's really the same algorithm, but this one, if we multiply 3 by g, it gives you that one. Yes, ma'am. Okay, because whenever you do synthetic division, this exponent is always one less than the original. That's a good question. All right, what other questions do you guys have? Okay, let's do long division. I don't think any of your Algebra 2 teachers taught you long division with polynomials. I could be wrong. Last period they didn't act like they really remembered it. But do you all remember long division with numbers? Like from 5th grade or 6th grade? I don't know when you learned that. All right, so I'm going to make up, you don't have to write this down, but I'm going to make up a little long division problem. Hopefully it'll turn out okay. All right, so if we were going to divide this, you don't let me add a few more numbers. You don't try to do it all at one time and figure out the answer. What do you focus on if you were going to divide this by this? Just the 9 and the 3, right? So if you were going to try to figure out how many times 3 goes into 9, you would say 3. And so it's the same thing with long division. So let's set it up. You have this division box guy. What you're dividing by goes in the front. What you're dividing into goes underneath. So divisor in the front, dividend in the inside. So that first step I just did up there where I got the 3, that's actually the division step. And so we're going to do that step also. But right now we only care about the first terms. And so you basically are going to divide 4x cubed by 2x, But what I do is I ask myself, what do I multiply 2x by to get 4x cubed? What do you guys think? 2x squared. All right, so that would go, I like to keep everything lined up, so I would put that over the x squared term. All right, so let's go back to these numbers. What would your next step be after you did that division step? You multiply, good. And so you take that 3 and you multiply it by that whole number 32. So you multiply it by 2, you multiply it by 3. We're going to do the same thing with polynomials. We're going to take that 2x squared and we're going to multiply it by this whole thing. So we're going to multiply it by 1 and we're going to keep our terms lined up. And then we're going to multiply it by 2x. All right, let's go back to the numbers. What's your next step now? Subtract. Now, if you're going to make a mistake, this is where it's going to be, probably. So it's not as easy as just doing 98 minus 96. You have to subtract both of these terms. And so we have to change both signs. And so I get in the habit of, when I do this subtraction step, I change both signs and then I circle them just to remind myself that I did it. Now, if we've done everything correctly, this 4x cubed has to cancel out. If it doesn't, you did something wrong at some point. It does, so we're good. And then it's negative 6x squared minus 2x squared. Okay, let's go back to the numbers one more time. All right, what is your next step? What is your next step? Bring down. So in this case, we're going to bring down the minus 8x. And then you do it all over again. All right, so when I do the division part, I only care about the 2x and the negative 8x squared. And so you're going to ask yourself, what do you multiply 2x by to get negative 8x squared? Good. So that goes on the top of the box. And then we're going to multiply. We're going to multiply that negative 4x squared by this whole divisor. Okay. And now when I do this subtraction step, I'm going to change both of these signs. And then I'm going to bring down. All right, so you guys can do the last step on your own, please. Now there's a couple of nice things about long division. One nice thing about it is it will always work. No matter what you're dividing, you can do long division. It's not restricted like synthetic. And also, whenever you're done, that's the answer. You don't have to like try to add x's and figure out what it is. And then this one doesn't, not always, I mean, it's just, this one in particular doesn't have a remainder, so that's fine. So our answer down here is just going to be the 2x squared minus 4x minus 2. And then the other algorithm, we would take that and multiply it by the 2x plus 1. Okay, so looking at those two, what questions do you guys have about synthetic or long division? Good? You don't know yet? Okay. All right, so on the next example, we're going to find the equation of the slant asymptote. So what we do is we divide and drop off the remainder. Your slant asymptote is not going to have a remainder. It's just going to be like y equals 2x plus 1 or y equals negative x plus 4, something like that, the equation of a line. The remainder kind of becomes insignificant because at the end, I'll tell you why, because some people want to know why. At the very end, like if this was your remainder and you put infinity in, and you do 2 divided by infinity minus 3, that's going to be 0. So the remainder is going to come insignificant at the end. All right, but all you really need to remember is just drop it off. Okay, so because the numerator degree is exactly 1 more than the denominator degree, there is a slant asymptote, and we can find it by dividing. So can I do synthetic division on this one? No, because of this 2. That we can't do it. So what we're going to do is long division. We don't have to do very many steps of long division because we don't care about the remainder. So that's going to take off like a whole cycle. All right, so I'm going to ask myself, what do I multiply 2x by to get 6x squared? 3x. I do need to multiply. I do need to subtract. And bring down, kind of, but we'll do it. All right, then I'm going to ask myself, what do I multiply 2x by to get negative 2x? Negative 1. And then I can stop. So if you're doing synthetic division, it's just like one full cycle and then just the first step of the last cycle. And so the equation of the line, the slant asymptote, is y equals 3x minus 1. All right. Okay, let's look at example 8. We're going to do multiple things on example 8. So we are going to write this function in factored form like we did yesterday, that we've done a tons of time. Just hadn't called it factored form. All right, then we are going to find all the different types of asymptotes. So does this one have a vertical asymptote?
Yes.
Where is it? Good. Good job. Does this one have a slant asymptote? Sorry, I said the wrong thing. Does this one have a horizontal asymptote? No. So when we are deciding about horizontal and slant, we look at the original. We don't look at the factored. I mean, you can, it's just more work. So because the numerator degree is bigger than the denominator, there is no horizontal. All right, does this one have a slant asymptote? Yes. So to find it, we're going to divide, because the numerator is exactly 1 more than the denominator degree. Can I do synthetic division when I'm dividing by x squared plus 7x plus 6? Not synthetic. No way, Jose. So let's write it as our divisor. Put this guy on the inside, and this feels super overwhelming, but it's going to be fine. Trust me. Now we can fill in a 0 if you wanted to for that constant. It's in the end, because of the way we are stopping early, it's not going to matter. Okay. So you're going to ask yourself, what do you multiply x squared by to get x cubed? It's going to be x. Good. Now we have to do that. Multiply that x by all three terms of the divisor. All right, and then we need to be careful on our subtracting step. The x cubes cancel out just like they're supposed to. And then we're going to get negative 3x squared minus 18x. Is that right? Yeah, plus 0. All right, and then we're just going to do one part of the very last rotation, and it's just the division part. So what do you multiply x squared by to get negative 3x squared? Negative 3. And that is our slant asymptote. All right, so what questions do you guys have? Now, our standards specifically say to use long division, but if you can do synthetic, I am fine with you doing synthetic. It is not going to be on an FRQ where you are going to have to do it the way they want you to do it. All right, let's look at example 9 and 10, and then you guys are going to have a little time to work. So on 9, bless you, we're deciding about, first thing is a horizontal or slant asymptote. So to figure that out, we need to know the leading term up here in the numerator by multiplying at least the largest powers together. So what is that going to be? Good. So does this one have a horizontal? No. So we're just going to mark it out. Mark out A and B because they say horizontal. There is not a horizontal. All right, so now we have to look at what's left and decide if there's one hole and one vertical asymptote, or if there's no holes and one vertical asymptote. So what do I need to do to that denominator? We're going to factor it. All right, so I'm going to do it at the same time you guys are doing it, and I want to know what you choose. A whole lot of people chose wrong in my last class. It's tricky. So what do y'all think? You think C? It's D, and this is confusing. It might help you if you wrote it like this instead. So if you cancel that out and be like, okay, that's a hole, that's a vertical asymptote, that would have them both at 1. You can't have a hole and an asymptote at the same place. So because the numerator's degree is smaller than the denominator's here, that's just going to be a vertical asymptote. It's not going to be a hole. Super tricky. These multiple choice questions on this are so difficult to get right. Okay, one more. We're going to do a graph. This graph is not going to be super accurate. We're going to just use the information we have and do the best we can. All right, so it tells us that on the right side of the graph, we're approaching negative infinity. And on the left side of the graph, we're approaching positive infinity. So that sounds like a slant asymptote, where the left side is the high side and the right side is the low. So I'm just going to draw a slant asymptote, just randomly. Right? It also tells us that as x approaches -1 from the left, we're going to negative infinity, and from the right, we're also going to negative infinity. So what does that mean we have at -1? Yes, that is exactly what that means. So I'm going to draw one there. Right, and this is going to be a really weird graph. It's okay. All right, so I'm going to start on the left side. We're going to be close to the slant asymptote, but we have to curve to the vertical where we're falling down. So it's going to be something like this. Maybe not as wobbly as I did. Okay, on the right side of -1, we are also falling down. So this one is going to be kind of like this. It's weird. All right, so what questions do you guys have? That's a lot. And I thought we could do more today, but I was wrong. All right, let me give you guys your assignment.